Okay, we're going to go over your test review here for 4.1. In the expansion of ax cubed times 2 plus ax to the power of 11, the coefficient of the term in x to the power of 5 is this. Find the value of a. So what they're telling me is that there's going to be a term when I multiply these two things together, and it's going to be 11880 times x to the power of 5. It's going to be something like this, okay? But what I'm doing actually is I'm multiplying a monomial by a binomial right here, and this binomial is raised to the power of 11. So there's actually 12 terms here, and we're going to multiply this monomial by all 12 of them. But I don't really want to do that. I just want to multiply it by one of them so I can get this answer, x to the power of 5. So then I ask myself, okay, x to the power of 3 times what will give me x to the power of 5? Well, that's just going to be an x squared. If I multiply x cubed by x squared, it will equal x to the power of 5. So the term I'm looking for in this expansion is x squared. So what I'm going to do here is I'm going to say n choose r. Remember, n is 11 here, so it's 11 choose r times 2 to the power of 11 minus r times ax to the power of r. It's going to equal something times x squared. That's my target for this, okay? I'm just going to look at the x's on this side. That's not an x, that's not an x. The only x I have is right here. X to the power of r, which has to be x squared. So r is going to be a 2, is what that tells me. Alright, so I'm going to go work this problem out. Then I'm going to plug in a 2 for r and substitute all that. So I have 11 choose 2. This is 2 to the power of 11 minus 2, which is 9. And then we have ax to the power of 2. And this is going to equal something x squared. Okay, so I can do this in a calculator. 11 choose 2. If you have a calculator, go ahead and use it. Let me see. Here we go. Calculator. I go to menu, probability, combination. I'm going to type in 11, 2. That's going to tell me 55. All right, so this is 55. 2 to the power of 9. Let's go ahead and do that. 2 to the power of 9 is 512. And then I have an a squared and an x squared. Alright, so what I've found from this part is this part right here. What am I saying? I'm saying that this right here corresponds to this right here. Alright, so we still have to multiply all of this by ax cubed, because that will give me my x to the power of 5. So let's go ahead and write that out here. Let's do this in green, I guess. We'll say, okay, so we have ax cubed times, let's go ahead and multiply 55 and 512. Let's go ahead and do that. 55 times 512. Okay, that's a big number, 20,160. And this will be a squared x squared. And this is going to equal this. That's what the idea is. Okay. All right. So when I do that, I have this number 28160. I got a times a squared, which is a cubed, and x cubed times x to the power of 2, which is x to the power of 5. Okay, and this is going to equal this number here. And the idea is to try to find a. Okay. If I divide both sides by x to the power of 5, these will be gone. So this is really no big deal here. And then that's going to tell me that a cubed is now going to equal this divided by this. Okay. And I'll just take the cube root of that, or I can raise it to the power of a third. I can say that a would equal this value raised to the power of a third, which is the same thing as taking a cube root. Okay, so I'm going to go ahead and divide that. I'm going to hit Control Divide. I'm going to have 11,880 divided by 2,8160. All of this will raise it to the power of a third, which is the same thing as taking the cube root. and the answer will be 3/4. Something else I could have done is I could have taken the cube root, sorry, that's the square root, the cube root, so the nth root, we could say the third root, and then here I could just have copied that, and then delete the power. We could say it to the power of 1, doesn't make a difference, and that would give you the same answer, okay, showing you it's the same thing. Alright, so this answer is 3/4 for A. A will equal 3/4. Or you can say 0.75 if you're one of those people. Okay. Alright, next question. The heights of adult males. This is an interesting question. It's kind of a challenging question, really. The heights of adult males in a country are normally distributed with a mean of 180 centimeters and a standard deviation of sigma centimeters. 17% of these men are shorter than 168, and 80% of them have heights between 192 minus h and 192. What is the value of h? So these are the sort of questions that they ask you on Math SL tests. This one's from a couple of years ago. I think it's 2017, I think. And if you know what you're doing, it's not that big a deal. But if you don't, and that's the majority of students, I would say, this can be kind of challenging. And sometimes they can sit down and figure it out, but it's time consuming to do that, and you don't have any time. So, but here's what I'll do. I'll start this off. I see these words normally distributed, so I'm going to draw a normal distribution, which is a bell curve here. All right, and what I see here is that the mean is 180, so that goes in the middle. For a normal distribution, it's symmetrical, and the mean is always in the center. Okay. And it has some unknown standard deviation. Technically, we'd go like 3 standard deviations one way and 3 standard deviations the other way near the end, but not quite. And this distance here is called a standard deviation. In this case, we'll call it sigma. That's what they can tell me. So I don't know what sigma is. And then we just kind of piece together what they're telling me here. 17% of these men are shorter than 168. Well, here's 180 in the middle, so 168 is going to be over here. I'm going to go ahead and arbitrarily just drop it somewhere and call this 168. And since they're telling me 17% of the men are shorter, the area underneath this curve, since this whole thing is a probability density curve, 17% represent this area right here. We'll call this 0.17. That's going to be the area right there underneath this curve. Okay, to the left, we're shorter than 168, since this is going, by height right here. All right, so 80% of them have heights between 192 minus h and 192. Now, I noticed something right away when they throw out this number 192. I know the distance between 168 and 180 is 12. And also the distance between 192 and 180 is also 12. That's done quite deliberately in the question to show you the symmetry. So if I have a value here called 192, I actually know that the area to the right of 192 is equal to the area to the left of 0.17. I mean, to the left of 168, which is 0.17. This is symmetrical because the distance from here to here, let's do this in yellow, the distance from here to here is the same thing as the distance from here to here. It's symmetrical, they're both 12. Okay. They're also telling me that there's another distance here called h. If I subtract h from 192, I'm going to go to the left this way, and I'm going to end up over here. And the area in between those two values will be 80%. But what do I have already? That's really the question. What's the area here, and what's the area here? Well, as it turns out, since this is half the distribution, just this half right here, and this is 0.17, this means this is going to be 0.33, and this one's going to be 0.33. So the area in between here and here is going to be 0.66. So I want to go 0.8. Let's do a different color here. I don't have too many good colors to look at here. Let's try that one. So I want to go from here backwards, and I need to go 80%. And this is only, if I want to go this far, it's only what, going to be 66%. So I have to go further. And that's going to be probably about right here, we'll say. And this is going to be called 192 minus h. And the area between here and here is 80%, this entire area. And this distance from here to here is called h. It's this whole line right here. And that's what we're trying to find in the question. Okay, so here's the deal. I can correspond this area here. I actually know this area to the left. Let's do this in a different color. Not too many colors. Purple, dark purple. We could try that. No, let's not do that. Let's do something that'll pop out and be really obnoxious, like this green right here. Okay, so if I color this area to the left, I actually know the area to the left of this, and here's why. I know this is 0.17. I know this entire area is 0.8. So if I add those together, that's 0.97. So the area here is 0.03, the area to the left of 192 minus h. Now, what I'd be tempted to do is to try and figure out this value h using a z-score. Because if I can find a z-score that corresponds to this value, I can use this formula here to solve for that h. And I would do this by using what is called a standard normal distribution. A z-score maps any normal distribution like we have this one here to a standard normal distribution. So a standard normal distribution has this property. Looks like a normal distribution. Everything's pretty much the same except the middle, the mean, will always be 0. And the standard deviation, this distance here, will always be 1. Okay, that's called the standard deviation. And that's how we standardize things. So we have values on the bottom here that correspond to the values on the bottom here. And we relate them together by what is called a z-score. So here's what I'd be tempted to do. Here's what I'm trying to do. I'm trying to find a z-score that corresponds to this 192 minus h. Because I know the area to the left of this z-score is the same as the area that I have on the left of this value, 192 minus h, and that's going to be 0.03. So I know this area here is also 0.03. And I can find the z-score from a standard normal distribution using what is called an inverse normal on the calculator. So let's actually go ahead and get that z-score. Okay. So here's what I'm going to do. I'm going to go to, since I know this area to the left is 0.03, I'm going to get the calculator open. I'm going to go and just make a new document here. I'm going to go to, let's see, data and stats. No, I'm going to go to just add a calculator, go to menu, probability, distribution. I'm going to do what is called an inverse normal. The area to the left, as I said, was 0.03. This is a standard normal distribution, so you want to keep your average as 0 and your standard deviation is 1. So I hit OK. And this z-score is negative 0.188. So this z-score is negative 1.88. That's what we have here, okay? And I have to try to find a way to relate this to this so that I can solve for h. And we can do this with what is called a z-score formula. The z-score formula is this. Z is equal to x minus mu over sigma, okay? So we actually know the z value right here is this guy, okay? This x that I'm talking about, we call that 192 minus h, okay? This mu is the average over here, which is 180, and this sigma, I don't know what it is. That's the unknown standard deviation, which they haven't told me, this thing right here. So here's the problem. If I were to substitute this back into x, which is what I really want to do, okay, then I would have two unknowns. I wouldn't know h and I wouldn't know sigma, so I couldn't solve this equation, all right, without knowing the sigma. So the idea, unfortunately, we have to find sigma first. Once I find it, I can go back and plug this in for x and I can find the value of h. So that's a whole separate step. And this is where that part would just confuse most people, right? But I know I can do this because I know another value, and that other value is 168. I know the area to the left of it, and that's what I'm after. So if I use 168 and have a z-score that corresponds to that, I know this area here will be 0.17. That's what I have over here, the area to the left of 168. And everything else is the same here. The standard deviation and the mean is 0, standard deviation is 1, everything's being the same. So I'm going to find this z-score, use this formula, and backtrack and find sigma, okay? Because that's something I don't know. And I will know the x value that corresponds because that'll be 168. So these steps can be confusing, and hopefully I'm not talking too fast, but I'm going to go over this, do this inverse normal process again, and I'll show you what's going on. So I'm going to do the menu distribution, inverse normal. This area to the left is 0.17 now. Mean and standard deviation are 0 and 1. I hit OK. So this is negative 0.954. Okay. So this is negative 0.954. All right. And that z-score right here will correspond to this value 168 because the area to the left of both of them is the same. So now I'm going to go back and use this formula, and now we can solve for our unknown sigma. Let's use a darker purple. Okay, so here's what I'm going to say. That z, which is my negative 0.954, is going to, this is my z-score right here, this one right here. And my x that goes with it is 168. That's not an unknown. The other one is an unknown, but I know this one's 168. And this mean is again 180. And the only thing I don't know from this formula is the unknown sigma. I don't know my standard deviation. But I can solve this formula for the unknown sigma. Okay. What I'm trying to figure out, oops, let's not do that. What I'm trying to get from this is this unknown sigma right here. And I can actually insolve this equation now. So let's go ahead and do that. And remember, if you have an insolver, go ahead and use it because it saves you time. Ordinarily, I wouldn't be a fan of using insolve, but it's a time saver, honestly, and you need to save time. So this is negative 0.954 equals, control divide, 168 minus 180 over an unknown value, which I would usually call sigma. I'm just going to call it x, and hit comma x. Okay, solve for x. That x is the standard deviation. It's 12.58. We'll call that. So what this tells me now is that sigma right here is 12.58. I found it. This thing right here. So now I'm going to go back and use this distribution to find the answer. Okay, so I'm just going to do this over here. We're going to say now my z-score, which is negative 1.88. We're using the same formula right here. My z-score is negative 1.88, and this x value that I have is going to correspond to 192 minus h. We're going to go ahead and subtract the mu, which is 180 still. And now we know the standard deviation on the bottom. We found it as 12.58. So now finally, after all that work, I can solve for the unknown h. And that's what they wanted me to find. So if I do that, put that in a calculator, let's insolve it again. Menu, algebra, numerical solve. Let's do this. This is going to be negative 1.88 equals, control divide. I'm going to put this in parentheses here. 192 minus h, some unknown h. We'll actually call it h. Here we go. And then minus the mean 180 over this new standard deviation, which is 12 point, what did I say that was? 12.54, 12.58, sorry, 12.58. Let's keep it consistent. Okay, so I hit enter. Wait, solve it for h now, right? So hit comma h, enter. So this answer is 35.65. That's the value of h, or somewhere thereabouts. So that's going to be my answer here. I'm going to say that h from this process is 35.65. And that's my answer. Okay, so this h value right here is 35.65. And that's the answer to this question. And that's what you have to do. And like I said, that's kind of tricky. But we'll do a lot more practice prior to when you actually take your exam, so you can't forget that. Okay, so sorry to take so much time on that. That one was kind of long-winded because of the explanation, but like I said, once you practice it, you could probably do that in just a few minutes, but you have to know what you're doing, of course. Number 3 is not so hard. Two events A and B are such that this the probability of A is 0.2 and the union of A or B is 0.5. Given that A and B are mutually exclusive, find probability of B. If they're mutually exclusive, they can't happen at the same time. Okay, it's like me saying probability of A is me driving a car and probability of B is me driving a truck. Can I drive a car and a truck at the same time? The answer is no. So the intersection of A and B would be equal to 0 because what? The events would be called mutually exclusive. They can't happen together. One rule that we use for this right here, this actually ties in the union and the intersection. We call this the addition law. Okay, this is the compound events rule. This is always true whether they're mutually exclusive, independent, or neither one. Here's what we're going to say. This is always true. The probability of A or B is equal to the probability of A plus the probability of B minus the intersection of A and B. This is always true, no matter the situation for two compound events. But here's the deal. This intersection is equal to 0. So this is really 0. It's nothing. Okay? So really what I have here is this part. And now I'm going to solve it because I know this and I know this. And the only thing I don't know is probability of B. And I'm going to solve this equation for it. I'm actually going to say that the probability of B is equal to the probability of A or B minus the probability of A. This is actually how I would do it if I were writing on a test. I would say this is equal to 0.5 minus 0.2, and this answer quite obviously is 0.3. Or you can even write it as 3/10 if you're one of those. Okay, so that's fine. Okay, given that A and B are independent, so they're changing the condition. First it said it's given that they're mutually exclusive. Now what if they were independent instead? Okay, how would that change my answer? What's the probability of B this time? Well, if they're independent, that means this is true. The intersection of A and B would equal the probability of A times the probability of B. And this would be true if they were independent. So this part right here, I'm going to substitute this instead for that. This part's going to go into here. Okay, so I'm going to rewrite this equation. And I'm going to change this last part. So I'm going to write this as the probability of A and B. Sorry, A or B is equal to probability of A plus the probability of B minus the probability of A times the probability of B. Let my board catch up here. Okay. Alright, so here's what I'm going to do this time. I'm going to subtract probability of A from both sides. Oops. And I have this now, just rearranging stuff. So all I do is subtract this part from both sides, and now I see on the right side I can factor the probability of B. It's the probability of B right here. Okay, I can factor that out of both of them, out of both these terms right here. So I'm going to do that. I'm going to say this is the probability of B times 1 minus the probability of A, which is true. And I have this now. So this is really just algebra. And now I'm just going to divide both sides by 1 minus the probability of A. So this and this are out, and this tells me the only thing I was looking for, which is what? The probability of B. So let's find it. So it's equal to this. So the probability of B is equal to the union, which is equal to what? We said that was up here as 0.5. Probability of A we already know from the question is 0.2. And what is 1 minus 0.2? We call that 0.8. So this answer is going to be 0.3 over 0.8. We can write that as 3/8. Or if you like using calculators, we could say 3 divided by 8 and put a decimal point on it, and it's going to be 0.375. Either one. Okay. Stop that for a sec. Alright, in this question we're going to find the term in x to the power of 6 in this expansion. Okay, so this is going to have 10 terms in it, this binomial. We want the one that has the x to the power of 6 in it. Alright, so we're going to use the binomial theorem, well, at least the part of it that gives you a single term. So we're going to say n choose r, n in this case is 9, so we're going to say 9 choose r. This is going to be x to the power of 9 minus r, and then 2 to the power of r is going to equal something x to the power of 6. Pretty standard stuff. Okay, this is the only x term that I have right here, so we can pretty much see that 9 minus r has to equal 6. So in this case, I can say easily that r is going to have to equal 3, okay, because 9 minus 3 is 6. We can ignore the non-x terms, okay. So let's plug that 3 in for r. We got 9 choose 3 this time, x to the power of 9 minus 3. 9 minus 3 is 6, which is what I wanted, of course. And then 2 to the power of 3. All right. So 9 choose 3. We can do this on the calculator. Go menu, probability combination, 9 comma 3. It's going to be 84. So that part's 84. And 2 to the power of 3 is 8. And then x to the power of 6. Okay. So we'll just multiply that by 8, whatever that is, times 8. And it's 672. X to the power of 6. That's this answer. Not much to it, really. Alright. Hints. Find the term x to the power of 7 in this expansion. Hints means use the answer I just found. Okay? So what I really have here is the same binomial. This thing right here. This binomial is the same as the one I had up here. So what they want me to do is to multiply one of these terms by 5x. But if I multiply this term that I have by 5x times, well, we have x right here, times x to the power of 6 will give me x to the power of 7. So all they're really asking me to do is to multiply 5x by this answer. That's really how easy that question is. Okay, so we say 5x times this one term that I have right here. Let's just multiply this answer by 5. 3,360. And then we got x times x to the power of 6, which is x to the power of 7. That's what I wanted, so this is the answer. Okay, it's kind of a goofy question, but you know, I say that, but people do miss it, to be honest with you. So number 5, the following diagram shows the function of f of x between -6 and -2. Sure does. The following points, -6, 6, which is right here, -2, 6, which is right here, are on this graph f, and the minimum point is -4, 0, which is right here. So that's all true. Find the range of this graph. The range, of course, is a set of permissible y values. So the smallest y value here is 0, and the largest y value that we see here is 6. So we have all the y values between 0 and 6 right here on this graph. So the range, we could say, is interval from 0 to 6 inclusive. This is an interval notation. Or we can write this as 0 is less than or equal to y, which is less than or equal to 6. Okay, remember that the range is a y. And how many times do I see x appear in this notation when we're talking about a range? Too many times. Okay, it's really unfortunate. So don't mix those up. Okay, so let's erase this part. We're going to have another graph called g of x. Okay, so it says right here, g of x is equal to f of x minus 5. X minus 5 right here is a horizontal shift, okay, 5 to the right. So we're going to move every point 5 to the right. So this point's going to go 1, 2, 3, 4, 5. This point's going to go 1, 2, 3, 4, 5. And this point's going to go 1, 2, 3, 4, 5. And they want me to, of course, on the grid above, sketch this graph. So we're just going to connect these dots. These questions really couldn't be easier. Something like this, okay? And write down the new domain for this graph. Okay, the domain is a set of y values. So we can see right here the smallest y value is -1, and the largest y value is 3. Okay, we can see that going up here and going up here. So it's the same sort of answer as the previous question. It's going to be from -1 inclusive to 3, or we can write it as -1 is less than or equal to x this time, which is less than or equal to 3. And remember, the domain goes with x, and what range goes with y. So just be careful there. All right, very easy question. All right, number 7, consider the geometric sequence. I'll consider it, where the first term is 768 and the second term is 576. All right, it's a geometric sequence, and the first term is bigger than the second term, so my common ratio is a fraction, is what this means. Find the least value of n such that the nth term of the sequence is less than 7. Okay, so let's write what we have really quick. We'll say u1 is equal to 678. u2 is 576. This is a geometric sequence, so I need a common ratio, and I can find that by dividing one term by the term that preceded it. So this is going to be 576 over 768. And the calculator, that's going to be 3/4 or 3/4, 0.75 if you want. Okay. And they want me to find the least value of n. N is the number of terms. We just say number of terms in the geometric progression. Such that it has to be a whole number, such that the nth term, whatever term that is, of the sequence is less than 7. Well, to find any term of a geometric sequence we're talking about, we're going to have to say that's going to be un is equal to u1 times r to the power of n minus 1. Alright, they want this term right here to be less than 7. Well, to find that, I'm actually just going to set it equal to 7. I'm just going to say this is 7, alright? And this will tell me a value of n, which is probably going to be a fraction, and then we can work with it from there, going up or down by rounding. So u1 is 768, r is 3/4, and this is the power of n minus 1. So what I want to do here is I want to solve for n. I don't just use the calculator to do that. This is going to be nsolve thing again. So I go to menu, I go to algebra, numerical solve, and I'll say, okay, 7 equals, what do we want, 768 times 3/4, oops, to the power of n minus 1. N minus 1. And we'll solve this for n, comma n. If you don't use the nsolve, you have to use a logarithm to get in, which you can do, but it's more work. This is going to be 17.33, so here's what I'm getting from here. This progression will reach the number 7 somewhere between what? The 17th term and the 18th term. Now, because this is decreasing, right, we know that U16, U16, 17 rather, let's call it 17. Let's do this properly. U17 is what I mean, will be something greater than 7. And that U18 will be something less than 7. Because I will reach 7 where n is equal to what? 17.33 will equal 7, somewhere in the middle. Okay? This is not valid to say 17.33 because n is a number of terms and you can't have 0.33 terms. But what I know is because this is what? Decreasing as we go, that this value is going to be greater than 7, and if I go past 17.3, I'll be at something less than 7. So I'm going to round this number up. So I'm going to say that n has to be 18. And you could prove that in a calculator, right? You could plug in 17 for these values for n and 18 as well, and you'll find that this is true. Okay, so I want the sequence where it's less than 7. It will be less than 7 when n is 18. So I'm going to say n is 18. That's this answer. Okay, maybe you can follow that. Number 7, the equation here equals 0 has 2 distinct real roots. This is a quadratic equation, and when I'm talking about the number of roots, this immediately is a discriminant. When you're talking about a quadratic and the number of roots it has, they're talking about a discriminant. So find the possible values of k. A discriminant is b squared minus 4ac, and to have 2 distinct real roots, we know this value has to be greater than 0. Alright, so let's find the discriminant for this guy. Alright, so this is my a, this is my b right here, and this is my c. So I'm going to say that k plus 2 squared minus 4 times 1 times 2k must be greater than 0. It's my discriminant. Okay, so let's expand this out, FOIL this out. K plus 2 all squared is going to be k squared plus 4k plus 4, and then this will be minus 8k. It has to be greater than 0. I'm going to combine the k terms, so it's going to be k squared minus 4k plus 4 is greater than 0. So this is a discriminant we're talking about. We will need this to be greater than 0. But this discriminant happens to be, because they gave me these terms right here, this k plus 2 term, this discriminant happens to be a quadratic equation. So I'm imagining in my head that this is quadratic is greater than 0. If it's a quadratic, it's going to make a parabola. This parabola is not the same thing as this, okay? So don't think that. But we want this parabola to be above 0, and 0 technically is the x-axis. That's where y equals 0. So what I'm looking for are two roots such that I'm above 0. What values of k? So if I call this the k-axis right here, what values of k will get me above 0? Well, anything between here and here is below, so I need all the values, right, of x to go this way forever and that way forever that are above 0. So to find that, what I'm going to do is actually find the roots of this quadratic. We're trying to look for these 2 points, okay? So I'll factor it. So what are factors of 4 that add to make -4? As it turns out, it's going to be -2 and -2. So ironically, what happens here is since I have the same, right, factor, I only have one value where k is actually going to equal 0. So what I really have is not a graph that looks like this, but what I actually have is a graph that's going to do something like this, where this is 0 right here. Oop, that's not right. Where this is 0 right here. And this is the one value for k, and that's where k is equal to 2 when I set these equal to 0. Alright, that's where it'll equal 0 for all other values. For all other values, it'll be above, okay, just not at 2. Alright, so it's never going to be below 0. It's not possible for this graph to be below 0, but it can equal 0 when it's equal to 2. So what I'm going to say then is that this graph will be above 0, right? This quantity will be above 0 for all values except for 2. So we can say all real numbers where k does not equal 2, or something like this. Anything like that would be fine. So I could plug in any value for k that's not 2 into this original polynomial, and what? This graph will have 2 distinct real roots. When k is equal to 2, it won't. It'll have 1 real root. It is actually not possible for this graph to have no real roots. So this graph is always going to have real roots, but when k is equal to 2, it's only going to have 1, and when k is anything else, it's going to have 2. And that's what they're asking me. What are the possible values of k? All the values of k are possible except for 2. So that's this answer. Hope that makes sense to you. Okay, now we're on the final question, which is good. This is looks like a composite question. Composition function. F of x equals x squared minus 1, and g of x equals x squared minus 2 for all values of x that are real numbers. Show that the composite of f and g is equal to this. Now, this is something you should know very well from Algebra 2. This is a composition function. When I say this fog stuff that the people call it just because of the way it looks, what this means is I'm taking x and plugging it into g, and taking that answer and plugging it into f. Well, if I plug x into g, this is really just g of x, if that's the input for g. And then we're going to take that and make it the input for this function f. That's all this means, okay? We're not plugging in values or anything else, and this is all this is. So I'm going to take all of g of x, this is what g of x is equal to, and plug it in to both of these values of x right here. So what this really means is f of x squared minus 2, which means instead of this x right here, we're going to call this that x value x squared minus 2. And what are we going to do with this x? We're going to square it. So we've got to square this and then subtract 1. They want me to FOIL this out. So what I have here, x squared minus 2 all squared is going to be x to the power 4 minus 4x squared, and then plus 4, and then at the end here we have minus 1. So what I'm going to do is say, what is 4 minus 1? That will give me 3. So this is minus 4x squared plus 3. This, of course, is the same answer that they wanted me to have right here. And all they wanted me to do was show that. So that's all you really do, okay? Not a whole lot to it. These questions are really easy, and they're commonly missed. So, like many easy questions. So, there you go. Sketch the graph here. So this is the composite that I just found. They want me to sketch this graph. Alright, this is a chordic function. Its graph is strange looking, but what I do know is the end behavior of the graph, both ends of the graph will go up. What's going to happen in the middle here, I don't know, but I'm only going to get I'm only going to get at most 3 bends in the graph, because it's always one less than the highest power is the number of bends in the graph, okay? So, because this is difficult to draw without a calculator, and this is a paper 2 question, use the calculator. Let's actually put this in the calculator. So I'm going to go to Control Doc, add a graph, and graph this, and just take a look at what it looks like, okay? If you have a calculator, by all means use it. So minus 4x squared, and then plus 3. And as we can see, the ends of the graph, we call this end behavior, are going to both go up, and we have 1, 2, 3 bends in the graph, okay? So let's actually figure out what these coordinates are. I'm going to menu Analyze Graph and find this maximum, which looks like 0, 3, and it is, okay? That's the maximum point. And I'm going to find a couple other points. I'm going to find the minimum point right here at the bottom. That's going to be where the y value is -1, whatever that is. And then we're going to go to Analyze Graph and find some of these zeros. So let's find this x-intercept right here. That's really nice. That's going to be 1, 0, that x-intercept. And we go Menu Analyze Graph and find the other one, which is right here. And the reason I'm focusing on the right side of this graph is because when I look at my grid, I only have, what, the right side of the graph. Here's the y-axis right here, so I can only draw the right side of the graph. So let's sketch this. I know that 0, 3 is the y-intercept, so that's one of the points, okay? And then I have, looks like, and when I graph this, I have the coordinate 1, 0. That's my x-intercept, which is right here. So this x grid is actually way more spaced apart than the y grid, which can be tricky to draw, right, when they start changing it up on you. But please pay careful attention to that. We know there's another coordinate, 1.41. 2 spaces is 0.5, so we're just going to be above those 2 spaces barely. 1.41 is right here. It's about, if this is 1.5, I'm going to call this as like 1.41, and we're going to go down to -1, which is about right here. This is all kind of guesswork, by the way. It doesn't have to be exact, but this is kind of my minimum point. Okay, that's what I'm calling 1.41, because this is 1.5, so this is 1.41, and this is of course -1 right here on the y-axis. That's the minimum point I'm drawing. And the other one here is I have 1.73 and 0. It's my other. So 1.73. This is 1.75 right here, so we're going to go just underneath it. It's going to be like right here. And all I can do is really kind of sketch this, right? And actually, if I wanted to put another point at 2, I could do that. To find the point at 2, I could make a table if I really want to. If I really want to get creative and say at 2, this coordinate will be 3. So I can put that point in there. So at 2, it's going to be up here. At 3, it's going to be right here, actually. And this is actually a pretty precise graph, considering everything. And I can kind of sketch from here. All right. So let's just do that. So this graph is going to come through here like this. It's going to bend this way. I'm drawing on a smart board, so this is not going to be particularly great, but it's going to hit all these points. And this is just going to kind of go up like this. And that's the part of the graph that I'm looking at. So that's about the best I can draw. And that's that question, really. On the grid, they want me to sketch the graph. That's the best I can do. All right. The equation here, this composite function, and whatever I say this composite function was, we call this x to the power 4 minus 4x squared plus 3 is equal to k. All right. It has 2 solutions on that interval. Find the possible values of k. K is a number of some sort, okay? It's just a number, not an integer, but a real number of some sort. And whenever you have a graph equaling a number, you have to understand what you're going to do is graph 2 things. You're graphing this part, and you're graphing this part, and you're just finding where they intersect. But if it's a number of some sort, and I want 2 solutions, this is how it would happen. I could just draw, like, let's say this is where, let's say k were equal to 5 right here. That's a horizontal line. Let's say k is equal to 5. This is the horizontal line, right? Like this. And the reason this is tricky is because they chopped off half of the graph. But if this graph continued, it would do something like this. It'd come down here, and then it would bounce back up like this. Okay? And what's going to happen is if I keep drawing this all the way through, I would have how many solutions? 2 solutions where they cross. Okay? So if the horizontal line crosses twice, that's where I get 2 solutions. Now, as it turns out, there are spots where that won't happen. If I were to draw here, let's say this is where k equals 2. K equals 2. How many solutions would I get? 1, 2, 3, 4. That's bad. I don't want 4 solutions. I only want, what, 2. So I wouldn't draw all this. Well, technically they wouldn't take out points because it's not, the drawing isn't wrong. But this is showing you that this is the number of solutions I would get for what? For k equals 5 and k equals 2. I want 2 solutions. There's only a certain number of values that will happen. It'll happen for any value that's what? That's above 3 right here. Okay, you can't really see that one. Let's do it in, let's pick a different color. Maybe a darker purple. So any value above 3 right here. So let's do this on the calculator actually, and I'll show you. So let's actually get rid of this table. Hit Control T again, that might work. Yeah. And I'm going to actually just draw stuff. So if I say 5 and enter that, I get what? I get 1 solution here, 1 solution here. All right. If I had 3, I would get 3 solutions. I would get 1, 2, 3. So it has to be a value above 3. K equals 3 is not good. And anything above 3, I get what? 2 solutions. Okay. So that's what I'm showing you there. If I had anything above 3, I would get what? Always get 2 solutions forever. But at 3 itself, I would have what? I would have 1, 2, 3. So it can't be that. So k has to be greater than 3. Or there's one more we tend to leave out, the bottom, right here at -1. If I did a horizontal line here across the bottom, I would get what? 1, 2 solutions. So actually, as it turns out, k could also equal -1. That would give you 2 solutions. And everything else is not going to work. And maybe you understand that. Okay, so that's your test review, and I appreciate you watching, and I wish you the best of luck.